All right, so Reynolds Advanced Materials, we're located in Brighton. Basically, we sell liquid rubber, liquid plastic, things for making molds and castings. So we deal with all kinds of industries, everything from ornamental plaster to orthotics and prosthetics, a lot of sculpture, a lot of artists, a lot of tinkerers, a lot of MIT Media Lab, soft robotics, all kinds of things. So basically, I'm going to kind of show you guys a little bit about what we do as it relates to public art and sculpture. So if some of you don't know about liquid rubber, liquid plastics, what that all means, what a mold means, what a casting means, basically mold is just usually something to reproduce something as exactly as possible. So we deal with flexible materials like silicone and urethane rubber. So there I am pouring some silicone rubber. There's a mold of a moose bone that we have in our shop. So just to give you a sense of what the materials are. Again, this is kind of a classical approach to making a mold, very old-fashioned. This is one of our customers whose work you will see all over the city without probably ever realizing it's theirs. Boston Ornaments, they do a lot of restoration, a lot of brand new work. They know everything there is to know about plaster. The guy who owns it has been working with plaster since he was 3 years old. So anytime there's a brownstone that needs repairing or a new feature added, it's often those guys that'll do the work. And so here they are making a flexible urethane mold to cast some pieces into. And here they are taking the mold off of the finished cast. And here's the site where they're working. So all of these elements that you see, all of the architectural elements from the ceiling panels to the columns to the bricks, those are all cast into flexible molds. And it is a used car salesman's pool house. I can't tell you whose, but it's his very epic, very stylish pool house. Here's an example of some public art done with our materials. So this was for a piece, which I'll forward over to here. These are kind of process pieces, but here's the finished piece. I believe it was the largest solid cast resin piece or liquid plastic piece ever made at the time. And our parent company, Smooth-On, actually worked with them to custom formulate a material that could be cast in that thick of a profile and not distort under the heat, not crack, not have these issues. So here's a series of rigs that they built to handle it, handle the material, handle the molds themselves. So we do a lot of consulting on projects, a lot of advising on projects, even custom formulation of things. Right, yeah. So we're the distributors domestically, but we consult with projects that take place all over the world. So there you can see it all rigged up. The ladders give you a sense of the scale of it. This is an artist who was local for a while. I think he's moved on since, but his name is Timothy Horn. He was using liquid rubber as a final medium. So instead of casting a solid part as his end piece, he was making rigid molds out of plastic and then casting silicone and urethane rubber in them, kind of riffing on these Baroque, Rococo, really ornamental pieces. Kind of like Boston Ornament gone mad, I guess, is the idea. Antoniadis and Stone, they're a pair of artists who are continuing to grow and show more and more places. So this is a piece that looks like a big block of stone held upended by a little 6-pack plastic tab. So we helped them figure out what material they could use to support this piece, which is actually, it's foam, it's coated. So we do a lot of consulting in terms of someone has an idea, whether they're an artist, whether they're an engineer. They hear about us, they come into the store, they call us up, and we walk them through the process or we troubleshoot. Primarily we sell liquid rubber and liquid plastic, but we know a little bit about all kinds of other materials. I worked as a project manager for a public art studio for a while. My coworker worked for a glass artist for many years. So we have a good range of experience and we know how to deal with a lot of different material issues. And we enjoy the more interesting problems. So the more bizarre it is, if everyone says it can't be done, we're interested. This was a project that we consulted on recently for Boston Street Lab and the MIT School of Architecture. So let's give you a little sense of what they're making. It's a piece called the Uni Project, which is like a portable library that can be loaded up into a truck, carted across the country, and then deployed. And so part of it is these white bookshelves that you see in the background there, and then these yellow benches, which are actually these sort of spines or spikes made out of plastic. And they're rotationally cast. So they're liquid plastic poured into a mold, and it's rotated as it sets. And so these pieces, they can go on at night to cover the books to protect them from vandalism, from rain, from weather, all those things. And then during the day, they can come off, be combined to form benches, form seating for different kinds of event programming. So this is a 55-gallon drum of liquid plastic that they had, because they were cranking out all these pieces. And this was the rig that they built to do it. So it has to rotate at a certain speed on one axis and another so that it sets properly. So they, this being MIT, they built their own rotational molding machine, built their own motor assembly for it, their own controls. One of the machines did destroy itself, but they learned their lesson and applied those to the next one. So we helped them figure out how to do this project, how to make it happen, how to keep their costs under control. And it was a lot of fun. This is a piece by a student at the Harvard Graduate School of Design. He was tasked with reinterpreting the Frank Gehry wiggle chair. Part of, I guess the whole class was assigned basically a piece of furniture designed by an architect, which I thought was a reproduction. I thought these were all reproductions, because I was like, who would ever, because they're supposed to disassemble these things, cut them apart, reconfigure them, reimagine them, but they were the original pieces. So, valued at anywhere from $5,000 to $25,000. They were donated by a Swiss museum, I believe. So his concept was, it's the wiggle chair. It should actually wiggle. It should actually move and bend and be flexible. So we helped him figure out how to do that, and it meant replacing some of the sections with this flexible rubber compound. So it could actually unfold. It could lay out flat. You could sit on it a lot of different ways. This is a local artist, Tori Fair. She has some pieces at the De Cordova right now. She had a clear concept, a clear vision for her work, and that's usually where we start with artists or designers or engineers, is they know what they want, they just need to know how to get there. So our job is basically to talk to them and work through that process. So these were all cast pieces that she had done, which are fairly large. They're life-size figures, so being able to create the mold, figure out all the technical problems, all the troubleshooting can be difficult, and it's expensive material, so you don't want to just go fully in for it unless you know what you're getting into. This is a piece by Neri Oxman, again, an MIT-related thing. So her department that she heads up is called Material Ecology, I believe. It's about how we can respond to and react to, and it can react to us in terms of our built environment, in terms of architecture. So this was a piece where she was actually machining wax to make a mold, which is, we see a lot from the Media Lab, because they can do things like that. Rather than sculpting the original, they'll just machine it out of a block of wax. So they would machine out their molds, and they would cast liquid resin into it. The liquid resin, as it's setting, it heats up. So they found that the heat would melt into the wax a little bit, and you'd get this continually changing form. So basically, she kept casting these pieces to get sort of this iterative form, this really natural form. So she's really looking at nature and how we can learn these lessons from nature in terms of how things are constructed efficiently. We're working with them on some 3D printing of concrete right now. We work with the Media Lab in soft robotics, all kinds of things. So they usually give us the most challenging problems, the most specific criteria to meet. This has to go underwater, it has to withstand 500 degrees, that kind of thing. So this was a large public art piece that was done a few years ago now, but the original was made in cedar, all assembled. So this was another big project that our parent company consulted on, very similar to the plinth piece that you saw earlier in terms of being a very clear, very stable resin. So knowing about these materials, we can tell you what will work, what will last when it comes to public art, because a lot of things won't, and that's going to be a primary concern for any agency that's going to be sponsoring or involved in fabricating this. So we can give you a realistic assessment of, if I make it this way or that way, how long will it last? Will it change? Will it discolor? That kind of thing. So this particular material is designed to remain the same color, to not have any yellow shift. I mean, I'm sure everyone's familiar with seeing old plastic that's been sitting out, how it becomes brittle and changes color. So this is designed to not do that. And you can see this pink kind of structure there with the flap is a large brush-on silicone mold that they made. This is cedar. The original one was cedar. So it's also, figuring out how can you seal that properly so that you don't get any latching on of the mold making material to the cedar.
So what's the positive going to be?
So this was the finished piece. This was cast sections of basically a liquid plastic that cures to a solid state.
What is the lifespan of this?
Longer than you or I, or it'll stay around for a long time. It's pretty stable stuff. It's different than what you'll encounter in terms of common consumer goods, or even a lot of the liquid plastics that we sell. This is kind of a high performance material. So.
What is it? Is it a urethane?
Yeah, it's a urethane resin.
A urethane?
Yeah.
That's that type of plastic.
Yeah. It has to be the right formulation to be, certainly different environments will have different criteria. So if you're doing a piece that's going in Dubai, it needs to have higher heat resistance, higher points at which it'll deflect than something, say, going in New England.
How did you get that color?
So it's pigmentable. The base material is completely clear. It's like a water clear. It has no color.
So is that sort of casted and molded?
Yeah, so they
You
actually,
can see the striation.
yeah, they added the color right into it and poured it in these sections. So you can see there are kind of multiple sections that they casted in. But this was a first for her. She had never, as far as I know, I think she had done maybe one smaller piece before. But primarily her work is in cedar, these large assembled pieces of cedar. So often we're kind of the point at an artist who's branching out or looking to do something new. We can walk them through that process.
What would the production cost of a piece like that be?
A lot. It's a very,
Is it 100,000 or?
probably more than that, I would say. Yeah, I mean it depends a lot on what your labor costs are in terms of how much fabrication you're doing versus someone else. And there's a lot of options in terms of different prices, like what you can do with different things.
What was your actual role in the production? Like, is it, I mean, in terms of the pouring and the overseeing, or is it just that you provide the product?
It depends on the situation. So something this scale, we're usually going to be more closely involved. Someone is very often on site for part of it or consulting on it.
They hire you guys for that part, like there's a part of the management that goes to.
Yeah, sometimes, or sometimes, we'll get a call from the fabrication team that's tasked with making this thing. They might be familiar with bronze and lost wax and things like that, but they've never had to work with resin, so they'll call us and work with us that way. But we don't actually do any of the molding and casting ourselves, but we will advise on, we'll do everything but that, essentially. So this is a pretty crazy project. It was iRobot involved with DARPA. So soft robotics is becoming a really big thing with MIT, with Harvard, with Carnegie Mellon. All of the good engineering programs have these emerging soft robotics programs, which very often involve silicone rubber. And they're leaning more towards soft robotics because it's more natural in a lot of ways. You don't have to deal with these articulations that will also restrict the movement. So this is kind of like a soccer ball shape, I would say. It has all these individual cells that they can pressurize at different levels and inflate it and deflate it and make it roll across the floor by deflating and inflating different sections. So it's pretty bizarre to watch in action and pretty creepy. But it's pretty interesting stuff. So we love projects like this. This is Harvard University. I'm waiting for someone to scale this up to full public art size. This could just grab an egg, basically, was the test. So there's a lamination of two different types of silicone rubbers that we help them arrive at that when you apply pressure, one bends a little bit faster than the other, it gives a little bit faster than the other. So you can get these curling motions, these gripping motions, and have it grab something like an egg without doing it any harm. ChemBox, this is MIT's. There's kind of a rivalry, with any of these engineering programs. So one of them comes out with a soft robot, the other one has a different soft robot the next week. But these, again, are looking at how things move naturally, whether it's a caterpillar or a slug or a snail, getting away from kind of mechanical means and looking at nature as a reference. So we get a lot of calls from them, a lot of walk-in business and traffic from MIT, certainly. And that's kind of the overview of what we do.